Okay, here we go. Rotations. A rotation is when you turn something. So how do you do rotation? Like we're going to rotate XYZ 75 degrees around point P. How do we do that? Well, here's what's going on. We've got P right here. We got XYZ right here. So we're going to rotate it 75 degrees. So we have this line that I'm going to, well, it'll be on board, that we're going to rotate around. So P stays still. And the triangle rotates 75 degrees. So X will go, if you draw a line from X, and then you go 75 degrees away and draw an X, and you turn it, X is there, so the triangle will wind up right there, which is basically like this. The triangle turns like this to end up like this. Okay? That's the triangle just turning around. So this would be X, this would be Y, and this would be Z. Turning around a point. Now, to do that, you need a protractor, and we don't have that many protractors, so we're not going to do that so much of turning like that. What we're going to do is rotate it, but here you need to write down the definition first. We're going to rotate 90 degrees, 180 degrees, and 270 degrees. But here's the definition you need to write down first. And then we'll get to our rotations of 90, 180, and 270. All right, so we're going to rotate around a point called the center rotation by a certain angle amount called the angle of rotation. So we're going to rotate around the center rotation a certain amount, and that'll be the angle of rotation. So let's just look at moving a point. Okay, so we have the point 1, 2. So from the origin, we go over 1, up 2, because each of these squares is a half. So over 1, up 2. If we rotate it 90 degrees, we're rotating it counterclockwise 90 degrees. So instead of going over 1 and up 2, we're going up 1 over 2. Okay, up 1 over 2. And so now A prime for a 90-degree rotation will be the point -2, 1. See how we switch the x and y around and make the x negative. Switch x and y around and make the what was originally y negative. Okay? Now if we go 180 degrees, instead of going over 1 up 2, we're going to go back 1 and down 2. So that's going to be at the point -1, -2, which is just the opposite of both sides. So they're in the same order, just the opposites. 270, instead of going over 1 up 2, we're going to go down 1 to the right 2. So it's turned this far around. So it's going to be at 2, -1. So you switch around the numbers and make the original x negative. Okay, so if you follow this little chart, it makes it easy for 90, 180, and 270. Okay, you know the chart. So we're going to rotate this 90 degrees. Now, A starts out at the point 3,5. B starts out at the point 1,7. C starts out at the point -2,4. D starts out at the point 2, -1. I want to know where A prime, B prime, C prime, and D prime are at. Okay, so if we go back up here really quick, you flip them around, and what was originally y becomes negative. So if we flip these two numbers around, and what was originally y becomes negative, we get a -5,3. What's the next one going to be? -7,1. Next one? -4, -2. And the next one? 1, 2. So if we graph those points, A prime, instead of going here and here, we're going to go here and here. -5,3. B prime, instead of going here, here, we're going here, here. B prime, -7,1. C prime will be at -2, 4. Whoop. Did I write? This should be -2, -4, right? Because that's -2. No, that was at -2, 4. So I go -4, -2. There we go. Woo, Mr. Bierschbach. Having a little brain fart there. All right, C prime is here. D prime will be at 1, 2. So I'm going to erase some of these extra marks. And there's a 90-degree turn. Now, we look at this. Ooh, not quite big enough there. I don't have to solve that. Make it a little smaller. So we're going to turn them around the origin of this. So we turn there, we turn it like this, goes right on top of this. Okay, a rotation, 90 degrees. If we went 180, it would look like this. If we went 270, it would look like this. Okay, so notice, what quadrants were A and B in the original? What quadrant is this over here? 1, 2, 3, or 4? 1. When you turn them 90 degrees, they both end up in 2. C was in 2, it ended up in 3. D was in 4 and it ended up in 1. So it just moves one quadrant to the counterclockwise. 180 all the points would move 2 quadrants. 270, they'd move 3 quadrants. Okay? All right, A. If you rotated it 180 degrees around the origin, right now it's back to up 4. 180 degrees would go right to down 4 to be right there. That's where A prime would be. Okay? Right 2, down 4. All right. The first drummer in a drum line is 20 at the 20-yard line, and the sixth drummer is at the 35-yard line. Here and here. So then they're going to rotate. Everybody's going to rotate in a straight line. So they all rotate around, and B is going to end up right on the 50-yard line. Then they're going to rotate around B. So A is going to end up on the 40-yard line. Okay? What's the composition of rotations, the composition of transformations there? Well, the first transformation is a rotation which we use a small letter R for. We rotated around point A, and we rotated 180 degrees. So we rotated around point A. The center rotation was point A. We rotated how far? 180 degrees. That is combined with a rotation around point B prime, because here's where B prime is, because B started here, it ends up here. That's where B prime is. We're going to rotate around B prime 135 degrees. But this time, this is clockwise. So because it's clockwise, it's a negative 135 degrees. Now, they put theirs what the angle was first and then what the letter was second. Yeah, that's probably the right way to do it, but, you get the gist. Okay? So what's the combination of rotations for this one? First, we're going to rotate around E. Then we're going to rotate around C. So we're going to rotate around E prime. And then the rotation is 60 degrees clockwise. Is that a negative 60 or a positive 60? Negative 60. 60 degrees clockwise is negative 60. The next rotation is around C, because we're going to rotate around C and go like this. Well, it's 60 degrees back, so then it's a positive 60 degrees. Now notice how we have two rotations. It would basically be a slide, or it would be a reflection when we have two rotations, which is the next thing. Any rotation is a combination of reflections across two lines of rotations. Again, I'm not going to worry about this when it comes to the test of you guys knowing this, but know that that is a fact. In that the angle of rotation of the two reflections is half the angle of the rotation of what actually rotated. Again, not super important, but you might see that on today's homework just slightly with a problem. Okay, so a rotation. So if this rotates this way, it's a positive 60 degrees around point P. This rotation is a double reflection, so if you reflect and reflect again, it's like a rotation.